Good morning, everyone. Good morning. Good morning. Am I audible? Voice clear? Voice is clear. Good morning. Good morning. Yes, Kalam. Yes, Balu. Okay, Manish. Thank you. ठीक है. So, my dear students, in the last class, good morning, all good morning. So, in the last class, we have completed the introduction part. ठीक? Introduction part అయిపోయింది. Okay. So keep your NCRT book with you firstly. Which chapter we are starting today? Chemical bonding. IUPAC and other things we will complete or we will start after completing the chemical bonding chapter. ठीक है? Happy morning, happy morning. Yes, focus on that part now. Keep your NCRT book with you, part 1, class 11th, in which chemical bonding we are going to start. ठीक है? Start करें. ठीक है. So in the initial portion, still you will read the introduction part. Make this habit, you will not leave anything. You will mark specifically after reading that paragraph. You do not mark every time underline, no. Specific point, important points will only be written and it will be marked also. So what is the meaning of the chemical bond? Chemical bond is a force of attraction between the particles like atoms or ions that holds them together or that binds them together to form a stable molecule. To form a stable molecule, that is the meaning of a chemical bond. So still you will underline this one given. Attractive force which holds various constituents together in a different chemical species is called a chemical bond. Clear? So you will underline that one specifically. Other things are nothing to underline on this page. And then you can add this in your notes, this definition. We are starting with chemical bonding chapter. In chemical bonding, definition is what? Chemical bond is a force of attraction. Is a force of attraction between. Chemical bond is a force of attraction between atoms or ions. Atoms or ions that holds them together. That holds them together to form a stable molecule. ठीक है? Between atoms or ions that holds them together to form a stable molecule. Now, after this you can write, during this process, energy is released. During this process, overall energy is released. Energy is released. Hence, 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 potential energy decreases and stability or strength during this process, overall energy is released, hence potential energy decreases and stability or strength of bond increases. Stability or strength of the bond increases. ठीक है, written. General term it is that chemical bond is what? Attractive force generally between atom or ions that combines together to give a new species, generally a stable molecule. During this process or during the bond formation, energy is released. That means potential energy decreases and stability of the molecule or stability of strength of the bond increases. Then we talk about the types of chemical bonds. कितने होंगे भाई? What are they? Generally, we talk about strong bonds, and sometimes we discuss about weak bonds also. In this chapter, also it is given. ठीक है? Now, in this chapter, if you remember, you being repeater, you can easily recall. In this chapter, how many types of bonds we have discussed, or you have earlier gone through? In this chapter, how many types of bonds you have read earlier? Very good. Tell. Electrostatic covalent. Very good. Electrostatic bond. Electrostatic covalent, or better is electrovalent, and other is covalent bond. Very good, Vijay. Any other student? Which one? Covalent ionic coordinate also. Yes, Sajid correct. Vijay correct. Covalent ionic bond. What about coordinate bond? Yes, Sajid said correctly. Coordinate bond. Any bond is missing in this chapter? Coordinate, ionic, covalent. Which other bonding? Very good, Anu. Correct. It is. Yes, Saiti. Metallic bond is there, but in this chapter we are not going to discuss. Creative soul. Correct. It is. Yes. Ramya Royal, Kalam, correct it is. Hydrogen bonding. So in this chapter, we talk about ionic bond, or other name is electrovalent bond, in which electrostatic force of attraction is there. Other is covalent bond, in which extensively different models are given. And coordinate bond, slightly we talk about coordinate bond, in which dative bonds are mentioned in Lewis structures, and hydrogen bonding. Okay? So strong bonds are, which one we are going to discuss? One of the strongest is ionic bond. Then covalent bond. Then ionic covalent के बाद coordinate or dative bond. Coordinate or dative bond. And fourth is metallic bond, but ये हम discuss नहीं करेंगे. We'll talk about this one, covalent also, dative also. In weak bonds, we will talk about H bonding, hydrogen bonding, and other we are not going to discuss in this chapter. Each van der Waals forces. Van der Waals forces of attraction. ठीक है? Getting it? Yeah, ionic is the one of the strongest form, then covalent, coordinate metallic, yes, coordinate approximately, but in NCERT that comparison is not given. ठीक? Can I change the slide? We talk about the ionic or covalent bond. Yes, Bolt, hi, you can keep on writing the notes and simultaneously NCERT page numbers you have to mark so that after class you can read that. Like you will read this introduction part. Okay? Just read that portion also. Although we will do Lewis octet rule separately, but these are some assumptions, something given, still read this. Then you will read this portion. NaCl example, which is we are discussing now, next will be ionic bonds. Then you will read that portion. Then this information you will underline the bond formed as a result of electrostatic attraction between negative ion and positive ion. It is termed as which bond? Electrovalent bond. You underline further. Electrovalence is equal to the number of units, suppose number of unit charge on the ion. Like Na plus, it will be plus 1 electrovalency. So example, calcium is positive electrovalence of 2 while chlorine has negative electrovalence of 2. Okay, so now this part you will read up to this one. Then which part I will say? After 2 pages or after 3 pages, it is this one, 106 page number. This you will read after the class, this portion. Ionic or electrovalent bond. Okay, these are conditions given here, points given here too. Example given just for understanding, you can read. Then this is important portion here. Getting it? So that after class you are quite clear which part after completing the notes you will read from the NCERT. Page number 106 you will read. Up to which part you will read? Up to this part you will read. Lattice enthalpy. That's ठीक है यहाँ तक getting the idea. After class you have to read which pages from the NCERT. Everyone getting it? रिस्पॉन्ड नहीं कर रहे तुम लोग. ठीक है, good, very good. So going back to the notes, so we are now going to discuss about which bonding, ionic bond or electrovalent bond. Ionic or electrovalent bond. What is ionic bond or electrovalent bond? You all know that the bond which is formed by the complete transfer of electrons. What is there? Complete transfer of electrons between participating atoms. It is which bond? It is ionic bond. It is one of the strongest form of bonding. And what exists between the particles? There exists electrostatic force of attraction between cations and anions. Okay? So, and in your notes you can write that point, write down. It is the bond which is formed by, write down, it is the bond which is formed by complete transfer of electrons. Formed by complete transfer of electrons between participating atoms. Between participating atoms. Between participating atoms. Okay? Then in next line you can mention there exists electrostatic force of attraction. There exists electrostatic force of attraction. Electrostatic force of attraction between cation and anion, there exists electrostatic force of attraction between cations and anions. It is one of the strongest form of bonding. It is one of the strongest form of bonding. Written. Completely written these parts. In example, common example, NaCl. NaCl exists as Na plus and it is Cl minus. Take Na plus, from where derived? From sodium element, sodium atom. Na losing one electron. What is the configuration of Na plus? Inert gas configuration with 2s2, 2p6. Cl minus, inert gas neon, then 3s2, 3p6. Now, by the loss of electron, sodium achieves what? That is, octet is completed. Cl minus also, by gaining of electron, its octet is completed. So here it is written like this: Na plus and Cl minus. Then the term which you have underlined also, electrovalence or electrovalency. So what is the electrovalency of sodium here? Of Na will be +1 and electrovalency of Cl is -1. Take what is the other example given there in underlined part of NCRT, which I have said, read that electrovalent bond there. It is given MgCl2. Then you will say what here? Mg plus 2 and Cl -1 each. Same configuration for Cl, near inert gas neon, and then 3s2, 3p6, Mg plus 2, exactly neon configuration. Take, so here electrovalency of Mg will be +2, electrovalency of Cl is -1 each. आई बात समझ में? ठीक है, that is given electrovalency mentioned. Okay, the electrovalency is total loss or gain of electron, that is there. So on that element or on that atom. Now, after this, you can mention one point: ionic bonds are directional in nature. Ionic bonds are directional in nature. Suharshita, it is Cl we will mention. That's it. -1. How many Cl? 2 to balance the electroneutrality. That's why CaCl2 or MgCl2. Individually, always we write. Ionic bonds are which nature? Directional in nature. Sorry. Ionic bonds are non-directional in nature. Are non-directional in nature. So this point or this line is important for statement type questions. Now, how many of you can explain this one? Why ionic bonds, they are non-directional in nature. Let us see how many of you can elaborate it very precisely, or you can explain it but in a very brief mode, because it is difficult to read too much here. Any one of you which who wants to explain this, they are non-directional in nature, just say one line or just few words. Due to complete transfer. Okay, rocking Swaroop. So Swaroop is saying due to complete transfer of electrons. Any other student who can explain it, or they have earlier read so they can explain it fast, I think. Very good, Swaroop. You have tried. No bond making and breaking. No, Satish. Because charge is uniform in all directions. Okay, let us see. Complete transfer of electrons by Suharshita. Any other student? They want to explain the meaning of that they are non-directional in nature, means nature. Okay, the students, I think they want I should answer. Cannot show geometrical isomerism. Yay, Carla Pudi. He is going here and there. Yes, he is reminding me of geometrical isomerism. Good, but I will tell the reason. Wait. Okay, I think most of you have tried. Some have typed, some are still inside, they are struggling. So the point here is they are non-directional. Charge is same in all directions. Madhu is saying, okay, listen carefully. If I tell you one thing about covalent bond, that covalent bonds are directional in nature, so you can relate it very fast. Why? In covalent bonding, we say what? It's tetrahedral structure at proper bond angle, this much 109.5 degree, or we say it's a linear structure or trigonal bipyramidal. All these things we talk about in the covalent bonding, that proper orientation is there. Yes. But if you say in ionic bond, what is there? Cation attracted by anion in any direction. Anion attracted by cation in any direction. Only what is required? The requirement is that distance should be appropriate so that maximum electrostatic force of attraction is there. Tell me, yes or no? Maximum force of attraction in any direction. So that is why they are what? Non-directional in nature. आई बात समझ में? We do not want any direction. We just want what? A suitable distance where there is a maximum force of attraction between positive and negative charge in any direction or in all directions that is possible. आई बात समझ में? ठीक है, तो remember this point, elaboration I have given, you will remember it easily. Non-directional in nature. Now we talk about the properties of ionic compounds. Okay, now tell me, in class 9th or 10th you have done generally such properties. Tell me what are the properties you remember. Which properties you remember of the ionic compounds? Fast. You can write one point, just one point. Okay, 1 point came hard, very good. ठीक है. Okay. Some points are there: low conductivity, high boiling point, high melting point, boiling point. Very good, rocking this one. Very good, Hari. Very good, Sajid, Swati. High melting point, boiling point. Good insulators. Okay, so Harshita, because strong bonding, good insulator, soluble in polar solvent. Very good, Jyoti. Creative Sudev, high melting point. ठीक है. Now, clubbing up all these points. Ionic compounds are hard. ठीक है, they are hard and brittle and they are crystalline in nature. ठीक, can we say this point? They are hard, crystalline in nature and they are brittle. Means by applying the pressure, they will easily gets break down. And the second point, as it is said, conductivity. Now they are good conductors or bad conductors of electricity. They are good conductors or bad conductors. Tell me. Good conductors. Okay, good, bad. Bad. Kirtana saying bad, Yarshini saying bad, Hari Surya said bad, Sahiti bad, bad. They are both. They are both. They are bad conductors in their solid state and they are good conductors in their molten state or in aqueous solution. आई बात समझ में? Getting it? We can write these points later on, just discussing, because these points you can relate very fast. Okay, so they are bad conductors in their solid state. In solid state, ions are not easily mobile, not able to move, so they are bad conductors. But when you say molten state, mobility of ions are there. When they are in aqueous solution, even high mobility is there. So that is why this point we will add about conductivity. First point about hard, brittle and crystalline in nature. Okay, any other point? Third point. Okadi rundu mudu. Mudu point. 2 points completed. Any other point? Very good. They are polar in nature. ठीक है. What happens? Solubility. They are soluble in which solvent? Polar solvent. Like, what is the best polar solvent? What is the best polar solvent? Yes, very good. Water. Amazing thing. See, water. Yeah, it is highly polar, and these compounds contains ions. They are highly soluble in polar solvent, but less soluble in non-polar solvents. ठीक है? So these are the some points you can add in your notes. Properties of the ionic compounds. The first point you can mention. You can mention they are crystalline, hard, and brittle. They are crystalline solids, hard and brittle. Second point about their conductivity. They are bad conductors in solid state. Or you can, I'm dictating, okay? You can write. They are bad conductor of electricity. They are bad conductor of electricity in solid state and good conductor in molten state or aqueous solution, and good conductor in molten state or aqueous solution. Or aqueous solution. Take molten. Aqueous means in water you are making it soluble, that is aqueous solution. Molten means by heating substance melt down, that is molten state. ठीक है? So Harshrita, you are getting. Then next point is, which one I said? Solubility. They are easily soluble in polar solvents like water. They are easily soluble in polar solvent like water. Easily soluble in polar solvent like water, and less soluble in and less soluble in and less soluble in non-polar solvent, and less soluble in non-polar solvent. Less soluble in non-polar solvent. Other point you can mention, additional point not given in NCERT directly, they can show isomorphism. They can show isomorphism. They can show isomorphism. Example, FeSO4 with 7H2O water crystallization. And ZnSO4. So they can show isomorphism, means they have similar crystalline structures possible with some ionic compounds. Which example? FeSO4 with 7H2O and ZnSO4 with 7H2O. They are isomorphs with respect to each other, which means their crystalline nature or crystalline structures are similar. ठीक है? Take, so this part is not that property part is important, but next point is important, which already on 106 page 2 points given. Favorable factors for ionic bond formation. Favorable factors for ionic bond formation. So which part you can underline? You will underline this part here. You can tick those points. You can read after the class. These 2 points you underline or tick it, and you will underline this portion. Obviously, ionic bonds, this part you can underline. Already highlighted, yes, you can use highlighter in the NCERT also. This one, this part you can underline, highlight it. That where it is, ionic bond will be formed easily between which elements with comparatively low ionization enthalpy. क्या होना चाहिए? Ionization enthalpy low, and other element with comparatively high negative value of electron gain enthalpy. ठीक? Then most ionic compounds have cations from metallic elements. Generally, we say suppose NaCl, it is S block element, S block metal, and anions are from the non-metallic elements. Then important example which is given here, ammonium ion. Ammonium ion itself is made up of the non-metallic elements, nitrogen and hydrogen, and is an exception, clearly given here. Is an exception which is given here, term exception which is given here, and it forms cation of a number of ionic compounds. Okay, I hope that you are underlining it simultaneously. You will read above and below portion also. You will not leave anything. Take, so this point you will underline properly. Underline kiya? Now, So by using these 5 lines, if I ask you a question, what are the favorable conditions to form ionic bond? What is given? The ease of formation of positive and negative ions from the respective neutral atoms. One thing, arrangement of positive and negative ions in the solid, that is the lattice of crystalline compound. Which part again? This is the portion you will underline. These ammonium ion exception is there, that also you underline it. But ammonium ion contains no metal, but it is still ion. When it is NH4 plus, it forms generally ionic compounds. Then these 2 points you mark. Okay. Now, all of you, what are the favorable conditions to form ionic bond? If you remember it, just quote here one point. Which conditions favorable? Already these are given here. We have underlined it just right now. Can you tell which are the favorable conditions for ionic bond formation? Kalam said, low IE, more negative E. Very good. That are the 2 points. Any other point left? Low IE. Srinu said, very good. Harish Reddy said, okay, good. Low ionic potential. Was good. Any other point? Negative EA. More negative. Srinu, yes. Already underlined there, high negative value. High negative EA nahi aayega. Srinu, it is high negative delta H EG. Low ionic potential, good. Low IE, good. Dadi Peta, correct it is. Any other student? Any other point missing? Any other point missing? High electron gain enthalpy, correct it is. High negative value, Disha, Sai, Sneha said high electron affinity, correct it is. Ease of formation of positive and yes, correct it is. Large cation, small anion, that is not here to be mentioned. If it is given, fine. IE should be high, IE should be low. Manish, kids on a high IE. Kids on it should be low. Swati, low IE, correct it is. High EN. Electronegativity, we do not use generally term. Nagaraju, high lattice enthalpy, yes, that point was missing. Manish Chilla, yes, that point is missing. So all said 2 points, but now other point you are saying, which is lattice enthalpy should be high. ठीक है, 3 point हो गए. One is low ionization energy. Second, high electron gain enthalpy. Third, high lattice energy. One by one. First, the third point. What is lattice energy? It is given on next page. So after the class, you will read up to this part. Lattice enthalpy. Clear? Clarity is there that you will read today's part 107 page. It is up to lattice enthalpy. Previous page also 106. Introduction page. Then second page of that. These 2 pages with definition of electrovalent bond. And then 106 and 107. Clear these pages that you will read after the lecture. So lattice enthalpy means what? Lattice enthalpy is what? That it is the amount of energy required to completely separate, means break down, 1 mole of ionic solid into its gaseous ions, like NaCl solid. You are giving energy and breaking it into Na plus and Cl minus. That is the meaning of what? That is the energy release what? Lattice enthalpy or lattice energy. Clear hai? Are you getting it? So now we will write these things in the point form also. Chalo. Up to this point, getting it, which part to read and which part to underline. Now, going back to the slide and writing the points. Favorable conditions to form ionic bond or favorable factors for ionic bond formation. First is element forming cation. Element forming cation. Like NaCl example, easiest you can understand easily. In NaCl, which is forming cation? Sodium atom. Which is forming anion? Chlorine atom. So element forming cation should have low ionization enthalpy. This term ionization enthalpy, I am assuming that you people know already in general way. In detail, you will do it in the periodic table chapter, which is currently going on in the track 3 periodic table. Okay? So generally we are borrowing these terms from the periodic table chapter. Ionization enthalpy or ionization energy means what? Amount of energy required to remove the electron. Okay? To remove the valence electron from the isolated gaseous atom. So if you know it, it's very good exactly. If you do not know exactly, get the somewhat idea amount of energy required to remove the valence electron from the neutral atom. So element which is forming cation should have low ionization enthalpy. Low IE is a favorable conditions for what? Ionic bond. Second, element forming anion should have high. Now in NCERT, what is term given? High negative value. So exactly copy it. High negative value of delta HEG, which is electron gain enthalpy, or we can say high electron affinity. Both are right terms. So favorable factor second, anion like chlorine is converted to Cl minus, it is becoming anion. So it should have high negative value, high energy released of electron gain enthalpy. Electron gain enthalpy means what? The amount of energy released, generally released. Exceptions you will do in periodic. So I am going by general meaning, amount of energy released when an electron is gained by an isolated gaseous atom. Cl gas, adding one electron, Cl minus, during this process energy released, that is electron gain enthalpy. So more is the energy release, more will be the favorable factor for ionic bond formation. आई बात समझ में? Two factors. Third already said at the end, which is lattice energy. So add this term, lattice energy should be lattice energy of the ionic solid form. Like this you can mention. Lattice energy of the ionic solid formed should be high. Lattice energy of the ionic solid formed should be high. Aditya, today it is normal regular class started, introduction completed in the last week. Now chemical bonding started today, and this will not be repeated. This is main track started. ठीक है? So these are the favorable factors for ionic bond formation. First, cation forming element should have low IE, anion should have high electron gain enthalpy, and third, lattice energy of the ionic solid formed should be high. Means more energy released during the ionic solid formation. ठीक है? लिख लिया ये? ठीक है? Now, next you write definition of lattice energy, which underlined already on page 107. Write down the lattice energy definition. lattice energy definition. लिखे? Shall I dictate it? Ready? ठीक है. It is the amount of energy required. It is the amount of energy required or released, amount of energy required or released when 1 mole of ionic solid, when 1 mole of ionic solid when 1 mole of ionic solid is broken down or is broken down or formed is broken down or formed from its isolated gaseous ions, formed from its isolated gaseous ions. लिख लिया? बोलो. Completed? It is the amount of energy required or released when 1 mole of ionic solid is broken down or formed from its isolated gaseous ions. ठीक है? In this definition, both terms I have mentioned. In NCERT, they have given in the definition amount of energy required. Why? Because they are giving in terms of breaking the ionic solid. They are giving in terms of breaking the ionic solid. That's why it is required. But if you reverse the reaction, not breaking, if you are forming the 1 mole of ionic solid, then also magnitude wise that value is same, only sign convention will change. Like if it is energy given, it will be endothermic plus sign will be used. And if it is an forming ionic solid formed, it will be energy released, it will be exothermic. So it will be negative sign. So in this definition, both terms are there. Released and what is written? Isolated gaseous ions, respectively you can mention. Respectively means in sequence. Required when it is breaking down and released when it is forming. So you can say isolated gaseous ions respectively. Take now example which is given here in NCERT with the data. It is of NaCl. So what is the term mentioned? We can say this is Na plus and Cl minus. NaCl solid, and here the energy involved is lattice energy. Now tell me what's the value given in NCERT on page 106, which I have already said to read it, that crystal structure given. At the end of this page, the value is given. Tell me which value given, how much? That is enthalpy of NaCl formation is given there. In minus it is given. Last. Yes, Durga Prasad, correct. Are Sidhu, read here. Later on we will talk. Vijay, yes, correct. Manish Challa, correct. Very good. It is minus 788 kilojoule per mole. You have to learn it? No. Just writing it so that you understand the value is which one? Negative. Means when 1 mole of ionic solid is formed from its isolated gaseous ions, the amount of energy released is lattice energy. Minus is meaning there. If I write opposite, NaCl solid into its Na plus and Cl minus ion, it will be plus 788. That is the meaning. That is the definition you have written. It depends upon which part is given. So if I write this one, suppose this is completed. ठीक है, ये लिख दिया. Now if I write, now tell me, is it also correct representation or not? All students, this is also correct representation or not? Is this is also correct representation or not? Vijay answered given. Okay, Vijay saying yes. Durga Prasad saying yes. Let's see how many of you considering yes, how many no. Suharshita saying yes. Harish saying yes. Other students, Yashaswini saying yes. Okay, let's see how many. Is there Madhu saying yes? Disha saying yes. Yes. Samira, Bhanu. Okay, Bhanu, Dadipeta correct hai. Swati correct hai. Anuguru correct. Durga Prasad. Now Durga Prasad saying no. Why Durga Prasad? Now you have changed the answer. Anu saying yes, Hari Prasad, Hari saying yes, Kalam saying no, Creative Soul saying yes. Out of these students who have responded, 2 students are saying no. Durga Prasad has changed the answer and Kalam Ramya Royal is saying also no. These 2. Okay, Durga Prasad, can you explain why? Sneha saying yes, let's see, answers are there, very good. Josna saying no. Josna, you have to mention why. Those who are saying yes, that I will discuss also. Srinu Mulas, yes, you have given the answer also, very good Srinu. 1 mole is there, yeah? 1 mole of NaCl solid. Kalam saying 1 mole. 1 mole is there, Kalam. Now it's correct, Durga Prasad. Kalam and Durga Prasad. Units aren't mentioned. Earlier I can mention the same, no problem. If I write it like this, suppose I am writing like this. Lo. Preeti, sorry. Who said? Preeti, yes. See. Rakesh Kumar got it. Rakesh Kumar got it and 1 more student, Srinu Mulasa also got it. Answer is no. It is not the correct representation. Very good, Kirtana. You also got it. Der hai, durust hai. So here the point is, this is ion given. Is it ion? No. And what is the definition written? This, that. Last mein, isolated gaseous ions. Yes, Durga Prasad. Now you are getting the answer. So question can be framed like this. Among following options, which is incorrect representation? That's it. Lallu question. Isn't it Lallu? But that student who has learned the definition, whose concept is clear, they can easily eliminate the other options. So here, this is incorrect representation. आई बात समझ में? Clear the meaning? Chintu, now clear? I hope this is clear to you. Then next portion you can write here for lattice enthalpy, factors affecting lattice energy. Factors affecting lattice enthalpy. Lattice enthalpy directly proportional to the charge on the ions. That is charge on the ion Q plus and Q minus, cation and anionic charge. And it is inversely proportional to the size of the ions involved. That is 1 upon size of the cation R plus and R minus. So in short, you can say more is the charges on the ions involved, more will be the lattice energy. More is the size of the ions involved, less will be the lattice energy. Less will be the lattice energy. Okay? So these are the factors that affect lattice enthalpy. That point we are going to discuss where in the comparisons. Like in this example, using this point, directly proportional to the charge, inversely proportional to the radius of the ion involved, compare the lattice enthalpy among these ionic compounds. ठीक है, देखो, this comparison, firstly see, in these ion, which ion is common? Anion is common, which is Cl minus. Which is Cl minus. So what is different here? Cation is different. Cation is Li plus, Na plus and K plus. All are charged same, Li plus, Na plus and K plus. So difference is size of the ion. Lithium plus smallest, potassium plus largest. So you will use which point? Lattice enthalpy is inversely proportional to the size of the ions involved. So maximum size of K plus, it has least lattice enthalpy. Focus on this part right now. Syllabus and everything at the end you can ask, or at the beginning you can ask. But right now in the mid, focus only on the content or subject which is going on. So you will write which reason for understanding. You can say it is inversely proportional to lattice energy, inversely proportional to the size of the ions. That is deciding the answer for them. Next one, same. What is common? Anion being common. What is changing? Cation. Same case. Anion being common, anion is changing. Anion being common, sorry, cation being changing. Size of the cation increases, doom. That is enthalpy decreases. So here maximum LIF and least will be KF. Same point, same reason like first one. Third, what is same? Now cation is common. Li plus 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 common. Difference is F minus Cl minus Br minus. F minus Cl minus Br minus charge. Same difference is size of the anion. As size of the anion increases, lattice enthalpy decreases. Hence LiF and least will be LiBr. So first, second reason was first, second, third. All three reasons are derived from lattice enthalpy inversely proportional to the size of the ion involved. आई बात समझ में? Very good. Try next question D, E. ठीक है. In D, among them, anion being same, F minus is common. ठीक, cation different, Li plus 1, Mg plus 2, and aluminium plus 3. What's the differentiating factor here? Charge of the cation. More is the charge of the ions involved, more is the lattice enthalpy. So here reason you will write lattice enthalpy directly proportional to the charges involved. Answer is AlF3, that is 3, then 2, then 1. I hope Durga Prasad you are getting the answer, reasoning part. In fourth, why we are not taking size? Li plus Mg plus 2 Al plus 3. If you go by the size also, then also smallest size, smaller the size of the ion, more will be the lattice enthalpy. But generally, what is the factor is there? Charge factor is highly dominating. Charge factor is dominating. Getting Kirtana? And Manvit, this is not basics, it is first chapter. First chapter means chemical bonding started today, and weekend syllabus will be on that basis. It is not introduction part, it is proper chapter started. E, let us see how many getting correct. E, what is common factor here? Anion. O minus, oxide. Differentiating factors: sodium, magnesium, aluminium. Al plus 3, Mg plus 2, Na plus 1. Again, charge factor. Clear this example? The reason for E is again lattice enthalpy directly proportional to the charge. Here charge is plus 1 for sodium. Do not think 2 sodium are there. No. You have to see individual ion. We are just using 2 sodium for maintaining the electroneutrality. Okay, so charge as per the individual ion here, plus 3, plus 2 and plus 1. Same way, NaF and Na2O. Sodium common, differentiating factor F minus, differentiating factor O minus 2. Now, we will see by which factor? Charge factor, not generally by size factor, because here charges are different, size is also different. O minus 2 more than F minus 1. Charge and size factor, they are opposing each other, so charge factor dominates. Charge factor dominates, answer goes in favor of Na2O. So I hope you are getting these examples. Keep on writing the reasons, otherwise you will forget it. आई बात समझ में? Till this point clear up to F. You can write this question in next class. I will discuss. Till that time you can try. One question I am giving, and then you will read the NCERT, underlined pages, mentioned pages, notes, revise it. In next class we will discuss Fajan's rule and then start with the covalent bonds. So be alert, be aware with the class what is going on. Every class is important. This example we will discuss lattice enthalpy. Okay, among them if you want to ask up to F. Up to F, any question you want to ask. Which one? Suharshita. Which one? First, mention A, B, C, D like this, na? Discussion will be next class. We will not discuss today. Okay, students, for today it's sufficient. So in next class we will discuss the which part. This example remind me, and then Fajan's rule, and then we can talk about the normally which one? Covalent bonding. Okay, any question you want to ask in next class we can go for. Kirtana, which question? Mg3 N2 or Mg2 N3, sir? Mg2, what I have written? Mg2 N3. No, it will be nitride ion. It is, yeah, Mg3 N2. Correct it, correct it. It is +2. It is Mg3. Very good, Kirtana. Otherwise, next class I have started with this. It is nitride here, -3 और कितना 2 -6 हो गया, ये भी +6 +2 and 3. Okay, students, today that is for the from the chemical bonding side. Okay, चलो ठीक है, bye.